one of the most exciting last year was our participation to Lightsail 2. So with the Planetary Society. So Cal Poly developed the bus for that mission, and then we get to also participate to operations. It was all over this summer with the first sail deployment over the summer, and then the verification of the sail later on. So students are very excited about that.
It's time for another episode of the Cold Star Project. I'm here with Dr. Pauline Faure of Cal Poly. Thanks for being here.
Thanks for having me.
Yeah. So super early for you, early for me. I appreciate you getting up so early to be here. So how did you get to Cal Poly? What was the journey of that like? And how did you get into space and satellites?
Well, the journey was quite long because originally I was in material sciences for my bachelor master. But I suddenly decided, not suddenly, it was a dream of mine to study about space-related things. And this is how I get through the opportunity to go study in Japan along those lines. So I just went to Japan and studied about space in the mechanical and control engineering department, worked on a few satellites, managed a few satellites myself, and I just never quit space since then.
Right. Right. Yeah. And you've had the great opportunity and made those opportunities to travel around to different countries in Europe and go to Japan and come to the US and that. So you've traveled around quite a bit. And you've been at Cal Poly since 2018. What are you teaching there, and how has that been?
So for my first 2 years, I'm on a reduced load for teaching, and my main course is called Spacecraft Design, which is the capstone course of the Aerospace Engineering Department. 1 year long, well, 3/4 long course, during which the students have to design a spacecraft, sometimes several spacecraft, to address a request for proposal established by a customer. Spoiler alert, often we are the customer.
Sounds good. What do they need to know before they can get into a course like that? Obviously, they have to have some engineering.
Yeah, that's preferable. There's quite a few prerequisites. So because it's the capstone course, they have gone through or are going through the different courses proposed by the department curriculum. And so they already know some basis in orbit, in propulsion system, in thermal, and so on and so forth. And then the goal of that course is to bring all of that together from a system engineering standpoint, so they can relate the different aspects they have learned together into how to make a proper spacecraft or aircraft for the people on the air side.
Right. And so what size and utility, what functions do these craft have? Because I can doodle one for sure.
Well, that varies. Last year, we made them design a large-scale space mining system. We ended up with 8 crafts, all very large because of the requirements of the request for proposal. And this year, we have been downsizing and are going to the moon. So we are designing a lunar mission for full coverage telecommunication and navigation capabilities.
Okay, that's a lot of fun.
Spacecraft. Yeah.
So
yeah.
I imagine
it's like a great course.
I'm trying to put myself into a course like that and see how badly I would do. But so what kind of iterations do they have? Do they use CAD? Do they just sketch it? How does that work?
Yeah, so they do have software to use for when they get to the analysis part. The first quarter is really about understanding the request for proposal and talking with the customer to identify the customer needs and desire, and then turning these needs and desire into requirements from which they will derive them to go to certain design options, then trade studies to see which one might be the most appropriate for making the architecture. And then it's iterations throughout the years as I gain more knowledge and discuss most with the customer and understand better where they are going.
Okay. I'm really curious how you assign a grade to this, because I can imagine, like, at this point, they're pretty dedicated. They want to be there, right? I would imagine they show up and do their work. So how do you say this is a C and this is an A?
This is a very heavy course. They have a 3-hour session per week at least. So at least it's hours in class. And for the grades, well, we have rubrics and we have deliverables just like we would have in the industry. So we make them give us those deliverables to us like they would have to prepare if they were at job. So that varies from this requirement allocation sheet or a concept of operation or presentations. We also have partnerships with industry. So every year we go to different industry for them to present and receive some feedback. And those also match some milestone that we have in a project life cycle of the development of a satellite. And so for each of those milestones, they have to prepare the adequate deliverables, which is how we grade them.
Okay. That sounds really
trying
good.
not to give Fs.
Yeah, I can imagine. So they have some project management that they need to do, some scheduling, some industry connections. I like that a lot. So in your notes here, you're saying that you're working on a course about aerospace beyond engineering. What is that about?
Yes, so I'm an alum of the International Space University summer program in 2011. And in there, they teach you we have all these different people coming from different backgrounds and not only engineer people, but also sometimes business people and sometimes sciences, sometimes law, and so on and so forth. And coming at Cal Poly, the students really learn deeply and greatly in terms of engineering related to space or aerospace at large. But I had the feeling there is a gap to learn more about these other aspects that are still necessary, at least to understand to certain basics before you go to the professional environment. To bring that to the students and give them some notions about maybe space law and policy, what to do an aerospace business, what does that take, certification, licensing, all these kind of aspects that are not really engineering or design oriented, like the passion of our students, but yet you need to understand that because that can have actually an influence on your design too.
Agreed. Yeah, because we have regulatory bodies and they're handing out things like frequencies and saying yes and no, and for sure,
you cannot
who can
transmit
do what?
whatever you want. Yes.
Right. Or even make and do whatever you want. So I
yeah,
like
or even
that.
when you go to the moon, NASA has end of life procedures and such, so you cannot go on the moon the way you want, especially and such. So it's good to know that.
Right. Hey, this is Jason Kanigan, the host of the Cold Star Project and the founder of Cold Star Technologies. I've decided to do something new. I've started doing daily update videos on who I met and what I learned the previous day in the space field. And it's a great sort of follow me thing. You can learn what I learn. I'm meeting a heck of a lot of people and learning a lot of things really fast. And the space field is really disparate. There are tons of nooks and crannies to go into and explore, from legal, operational, regulatory, compliance, and gosh, the end customer. Who'd have thought about that, right? So you can sign up for this. If you go to coldstartech.com/MSB, that's short for Make Space Boring, the mission we're on, then you can sign up, and in your email you will get a daily notification that the new video has been posted. I'm also thinking about doing some branded mini courses and summarizing papers as I'm able to. So those will be some goodies that are in there as well. So if you're interested in that, go to coldstartech.com/MSB and join us on the mission to make space boring. Now back to the interview. You have been an advisor to Cal Poly's CubeSat Lab. Tell us about that. How many people are in there? How many students? And what are they doing?
Well, the lab is growing every year. I've been an advisor for the last year or so, and last year we had 70 plus students, and this year we are reaching close to 100 students. So it's a huge research lab, and we have maybe 90% of them are undergraduates, and they all come from everywhere. So it's not only aerospace engineering. We have computer science major, computer engineering major. We have electrical engineers. We have mechanical engineers, we have industrial manufacturing engineer, we even have some people from other colleges for PRs and help with our workshop and such things. So we have a huge pool of students. And then we have 2 faculty. So one of my colleagues is the director of the lab and myself. And then we have 3 research staff that are very knowledgeable about testing, relates more to with the customers for professional interactions, and so on and so forth.
Okay. Tell us about a recent project that they've done.
I think one of the most exciting last year was our participation to Lightsail 2.
Mm-hmm.
So with the Planetary Society, so Cal Poly developed the bus for that mission, and then we get to also participate to operations, and it was all over this summer with the first cell deployment over the summer, and then the verification of the cell later on. So students are very excited about that.
Right. Yeah. To get something made that's real and goes up and they get feedback on actual use. All right.
Yes. But the students also have been working last year on I've been working on the Marco mission. One that went to Mars to transmit. Some of our students were also helping with the operations. So we have a mission or so per year that is very high profile and enthusiastic for our students and ourselves too, of course.
Right. Well, other than that, what are some best moments that you've had so far?
Well, so far or every year when I launch a satellite is I have 2. The first one is actually one of my students asked me that the other day. And so the first one is every time I launch a satellite, there's something about the launch that is just so emotional of knowing all the work you've put in there and all that your team put in there. It also always feels like quite an achievement. And then from a teaching standpoint, seeing the student graduate every year is also very emotional for me because I know how much work they put there. It's not easy to graduate. It's not easy to be competitive on the market to get a job. And they work a lot and they put a lot of time and sacrifice, sometimes personal, despite the hurdle they can have privately or professionally. But yet they made it through. So it's always very impressive.
Okay. And what kind of hurdles do you see for space industry and students in that coming?
Well, the main that I've been focusing, myself, I'm not a US person. And so some of my students are also not US persons. And it's really tough when they go to career fair or other places and the first question, because it might be visible that they are not US person, is like, so are you a US person? And they say no, and they just, get out of the line. And that's very tough.
Yeah, I can imagine, especially after all the work they put in. I'm a permanent resident of the United States. I'm originally
congratulations.
Canadian, so thanks. So I've been through that whole process. I've been here 10 years, but I'm stealth, right? Nobody suspects. They just hear sometimes something in the accent that makes them think West Coast. That's about it.
I'm less lucky on that side. My accent is still fairly strong. But the industry, I think, is trying to get more diverse, or at least sees the necessity of being more diverse and inclusive, a better system. But this is a slow process in the aerospace side.
Okay. What do you think about women in the aerospace industry? There's more all the time, right? And I have enjoyed, like when I switched the focus of this show for the first 80 episodes or so, it was about the unexpected challenges of growing businesses. And I switched that to space and satellites. And there have been a lot more women to talk to in this field than there were back in business, which is interesting, right? There were all these men running businesses and that's it. And I kind of got tired of it. So from your perspective, how has it been?
Yeah, it's not always easy. Yeah.
What do you think about numbers? Are they increasing? Or is it the same?
For Cal Poly, they have been fairly the same in terms of enrollment, though next fall, I think we'll be 30% of female students.
Okay.
So that's fairly amazing for us. And hopefully that will help change the environment or certain biases that could be out there. Obviously, I do not think that women are less capable of anything than men making a space business. And I I know a few women who have a space business, at least in Japan.
Yeah, I just talked to one yesterday. So
Oh yeah.
they exist. Yes.
Was it Naomi Kurohara?
No, it was Laura. Where are you? Not
I
Laura
don't know.
Montgomery. She's a lawyer. I may have
Okay.
told her. Laura Forzik. She runs like
I don't know
a
that
space
person.
policy. Yeah. So let's see here. You have some ideas about enhancing the CubeSat lab. What if you had the budget, the money, the resources? What would you do?
Well, what we would like to do is probably going to larger class of spacecraft.
Mm-hmm.
That's one of our direction to address more complex mission like interplanetary mission and such. So we would like to develop also a bit more of our bus capabilities, either in terms of attitude control or communication or possibly propulsion to enable this mission or to enable us to compete better for those solicitations. And then, well, considering my background, going to various countries and working with different countries, either in developing or emerging nations, and my desire to use CubeSat as educational tool for STEM activities, my personal vision for that is to develop an international network with space nations so we can support each other accessing space and always increasing the number of space users at not especially a high cost that it used to be.
Right. Yeah. I mean, you can make. I remember talking with Rick Fleeter at Brown, and they made a SmallSat there for $5,000. So as long as you're willing to make all the components yourself, you can really drive.
Yeah, you have to be careful with that too, or the calculations, because I mean, the good thing with universities, well, the good thing is, yeah, so to speak, maybe not for the students, but yes, students are somewhat free labor, right? But once you go more professional, the price goes up.
Right. Yes, this is true. And yeah, and expectations, but you're also probably making more, not just one satellite at a time, let's say.
Yeah.
Did you know that the SmallSat industry has a 40% and greater partial and full mission failure rate? That's terrible. And yet I find most people in the space industry try to treat this as if it's no big deal. They don't even want to acknowledge it. And I think that's ridiculous. If anything, anywhere else was having a 40% or greater failure rate, trying to turn your car on, right? If your vehicle or your cell phone didn't work 4 times out of 10, 2 times out of 5 that you tried it, you would go berserk. And you would do everything you could to make sure that it got fixed. The SmallSat Process Engineering Department at Cold Star Technologies is all about showing you how to manage processes better, to eliminate the causes at the root that create these partial and full mission failure rates. And you don't need to hear it from me. You can look this stuff up in studies. It just comes out of what you might think are the dumbest things. Oh, I know that. Well, to know but not to do means you don't know it. You rush the production schedule, you don't manage it right, you don't have the project sponsorship set up quite right, and the resources aren't there. You've got this mission launch date that's moving, and you just throw the schedule out the window. 1/3 to 1/2 of your project schedule needs to be for testing. And yet, this is the first thing to get smashed in the head by a wrench. As soon as the monkey wrench is thrown into the operation, testing time goes out the window. If you want to avoid this problem, the answer is not more physical engineering. It's not. More engineers are not going to solve your problem. You have tons of engineers. I am not going to tell you how to engineer a satellite. I've got Dr. Rick Fleeter and other people on my team for that. And we're not going to come in there and tell you how to engineer it. But on the process side, and I have had engineers on this show say, engineers don't know nothing about processes. That's not me saying it, it's the engineers saying it, but I will definitely echo it. If you want to have a manufacturing process that ensures that your SmallSats, CubeSats get up there and work, come talk to us at Cold Star Tech. What has stood out for you at Cal Poly compared to other universities about teaching space?
That would be the students themselves. They're very driven. They ask a lot of questions. They have really this will of understanding what's going on and why it is done a certain way and not another way. So the drive and the motivation of the students to come through almost no matter what is very impressive.
Okay. Let me ask you a question I asked Dr. Amelia Gregg on a previous episode. What should students, graduate students, be concentrating on about their job search as it's coming up, maybe in their final year and that as it's approaching?
Well, I'll give the same advice I give my students when they ask me is go also look for small and medium companies. And not everything, you don't all have to work for big companies. Small and so higher, and who knows, it might be a better fit for you. And just don't give up. Just keep applying. It's all right. And another thing that a lot of worries is about not having an internship, and so being worried about not finding a job. Again, just don't give up. Keep going. Be passionate the way you are in class, and you will do just fine at interviews.
Right. Now, about networking, people are often afraid to reach out and say hi to somebody that they've never met, and yet we have LinkedIn, for example, which is a great place. I met you through LinkedIn, right? Just
That's
tons
true.
and tons of space people are out there. How can a student use a social network like that to not like tap on people's doors and say, hey, have you got a job? But ahead of time, just get them to be familiar with you. Is there a way that you would recommend they reach out and start that?
I think I will start by first really wondering what is my interest, and then based on this interest, see if there are people having similar interest, and having a conversation based on that interest more than I need a job, can you help, type of discussion. You can also use the network of your university. Cal Poly has a lot of alumni are in the aerospace industry, and I think it's fine also to say, hi, I'm a Cal Poly alum. Maybe I saw you have that major and this kind of journey. I have maybe something similar. What would be your recommendation maybe moving forward? Or I think there are different ways of going through that.
Right.
Being
Okay.
on top of my mind.
Yeah, that's a smart way of starting, is like not trying to jump in there and say, hey, I want a job, but instead, hey, I noticed your organization works on these kinds of projects. I have a real interest about that. Tell me more. Like, you know, what are you struggling with? What is working really well? You know?
Hold on. Just on the last question, I will also say, talk to your professors or whoever teaching you, because we also have our own network, and usually we have no problem introducing you to them to start the conversation. So also use us, just talk to us.
Right. Yeah, there's a lot of resources or possibilities out there, like you just pointed out, that are kind of latent, right? They're hidden until you go and ask, and then the person like you can say, or me can say, oh yeah, I know this person, but we would have never thought about it unless we were prompted. Right?
Exactly. Like one of my students asked me, do you know anybody in Germany? And I was thinking, I was like, wait a second, I do know someone in Germany. And they're in the aerospace business. I put you in.
Right. And it's, it might be 2 people down the road from that person, but it's a starting point. So
exactly. Just got to start somewhere.
So let's see, before you got to Cal Poly, you did something called the LACEN trainings. What were they, where were they, and what happened there?
Yeah, so that was in Japan at the Kyushu Institute of Technology, and LACEN stand for, it's a mouthful, but Laboratory of Spacecraft Environment Interaction Engineering, which is directed by Mengo Cho, who is a professor over there. And through this, they have a testing center called CENT, the Center for Nanosatellite Testing, and where they have thermal vacuum chamber, thermal cycle chamber, shock testing, and vibration test. So they have developed a scheme to have customers coming professionally to test their various equipment. And from that, there was a demand from the community, the small satellite community, to also learn on how to operate those machinery and those equipment, because not everybody has the capabilities to actually have their own center. So they developed the first testing, which is a 10-day stress testing about using those different equipment, and this is combined with some lectures. So it's a really hands-on experience where people learn about the fundamentals of a space environment and the launch environment, and then get to practice on some dummy models, those testing. And then another testing that we created when we started capacity building type of efforts with Spruce Emerging Nations was a 3 months training on developing a mission for a CubeSat and manufacture the corresponding board, integrate, assemble, integrate, and test. And test functionally speaking, and test, of course, with also like the vibration machine and such.
Okay, testing, so important.
Yes,
One-third to half of your project schedule, folks. And yet people try to scrunch it in at the end. And that
test.
Yeah.
Yeah, and we had some study, actually it was part of my PhD too, that just showed that test doesn't have to be long or extensive. Sometimes, for example, just a 1 or 2 cycle of thermal vacuum could be enough to highlight the critical flaws of your system. And so it allows you to fix it to just enhance a little bit the reliability later on once you're in space.
Okay, well, let's finish up with this question then. Where do you see small sats going? What's the best next big development on the horizon for small sats, CubeSats?
Well, going back to our earlier conversation, there are definitely a larger push for interplanetary type missions. There is a NASA plan, obviously, to go back to the moon. We had the Marco mission technology proving that it could be feasible to have something around Mars. So I think interplanetary type of mission are probably where we're going.
All right. Well, my guest today has been Dr. Pauline Faure of Cal Poly's Aerospace Engineering Department. Thanks for being here.
Thank you for having me, Jason.